Hello everybody. So after we discussed calculating ANOVA and Tukey's post hoc, it's time to talk about Scheffe post hoc test. Okay, here we go. So let me just establish setting here before we start talking about this statistical procedure. We just want to evaluate the effectiveness of a financial aid training offered during the orientation to freshmen. So we have three groups of students. The first one is no treatment group, nothing happened, this is the control group. And we have the group that took short online training, and the third group, the group that took the course or the interactive workshop, 2-day interactive face-to-face workshop. And now we are comparing these groups, okay, through administrating, a test about financial aid loans, federal grants, FAFSA form, stuff like that. So now we want to see if there is, a significant difference, among those groups. We did an ANOVA test to see that. And now it's time, to locate where this difference is located, where, it is exactly, So, in fact, the ANOVA test tells you about, if there is a significant difference between treatments, between groups or not. Now, the post hoc tells you where this difference is between group 1 and 2, 2 and 3, 1 or 3. So that's why, we conduct those tests. Okay. So, for post hoc tests in general, they are done when H sub O is rejected, so your null hypothesis is rejected, and you accepted your your research hypothesis, H sub 1, and you want to locate this significant difference. So, of course, you need more than 3 treatments because, it's going to be t-test then if you have like 2 groups. So with K, which is like, the total number of treatments, groups, K equals 3, we compare a mu sub 1 versus mu sub 2 and mu sub 2 versus mu sub 3 and mu sub 1 versus mu sub 3. Okay, so we want to generalize the findings to the population means. That's why we're using mu here. This is all hypothesis. Okay, so it's a very good method, Scheffe test, for reducing type 1 error. And to know what type 1 error is, you need to go back to lecture 1. It uses the F ratio to evaluate significance of the difference between any 2 treatment conditions. We will see that now. Okay. Okie doke. So before doing Scheffe post hoc, 2 things to consider. K is used from the original experiment to compare degrees of freedom. Therefore, degrees of freedom for the numerator of F ratio is K minus 1, and K is the number of treatments. So it's going to be K3 here we have. It's going to be 2. The F ratio is the same as was used to evaluate the F ratio from the overall ANOVA. This is very important, as we will see. Now, calculating Scheffe post hoc. Okay, with the calculation now, exactly. Let's have this example first. We have treatment A with T equals 28 and N 10. So what is T? Okay, the summation of scores within a treatment. Good. And N is the number of participants. So this is like treatment A. Treatment B, T50, N equals 10. Treatment C, you have T66 and N equals 10. So now in this example we are going to compare between A and B. We have very limited time for this presentation. Okay. So G is the grand total, so it's like the summation of T's. 28 plus 50 because here we're comparing 2 groups, unlike the ANOVA, the general ANOVA, you have like the 3 groups. N equals 20. So 78, 20, we need those numbers from this slide. And now this is the equation we need to calculate, Scheffe. So F sub A versus B equals mean square between over mean square within. So we need to calculate mean square between. Now let's see that. To calculate mean square between, you need sum squares between, which is the summation of t squared over n minus g squared over n. And that's, so we have sum squares between equals 24.2. Remember that. Okay. So a mean square between equals sum square between divided on degrees of freedom between. So we have 24.2 divided on 2. Degrees of freedom is k minus 1. Remember that. So it's 3 minus 1 is 2. So now we have the mean square between is 12.1. Okie dokie. So before I talk about anything here, you need to remember that Scheffe test uses the error term from the overall ANOVA to compute the F ratio. Okay? So it's used from the overall ANOVA. So now we got mean square between, so now we want mean square within. Remember those, we used all of those during calculating ANOVA in 5380 previous lecture. So mean square within equals sum square within divided on degrees of freedom within, and sum square within equals the summation of sum squares, and the summation and the sum squares equals the summation of x squared minus the summation of x parentheses square over n. And degrees of freedom within, it's n minus k. So this should be from overall ANOVA, so it's going to be n like the total number of participants in all the groups is going to be like 30 minus k, it's like 3, it's going to be 27. Okie doke. Now we have our mean square within, it equals 5. In this example, degrees of freedom within, as we said, 27. Now back to Scheffe equation. F sub a versus b equal mean square between over mean square within, and that's 24.2 over 5. It's 4.9. So 4.9. Okie doke. Now, with degree of freedom 227, and the alpha level here is 0.05. Some cases in your research you have very conservative alpha level depending on what you're doing and your major. So the critical value of f is 3.35. So how we calculated this, let me show you. You need to go to the F distribution table. I have it here. Okie doke. So yeah, this is the F table for alpha level of 0.05, and this is the tail, the critical region in the tail. So we need, like, this is like 2. We need to have like 27, F2 27. Here we go. This is 27, and this is the F. Okay. Okie doke. So back to our presentation here. Okay, so with degrees of freedom 227 and a 0.05, the critical value of F is 3.35. And you remember the value we got for F sub A versus B was 4.9, and that's greater than 3.35. That means the F ratio we obtained is in the critical region. So the null hypothesis here is rejected, and we accept our research hypothesis that there is a significant difference between treatment A and treatment B. So that means, the online course the second group took, changed things. The group, is not like the group that didn't do anything, the control group. Okay, guys, and that's how you report your findings, APA style. So F2 27 parentheses, equals 4.9. p less than 0.05, the null hypothesis is rejected, and there's a significant difference. I hope you liked it. Thank you so much for watching. Bye-bye.